Hello, this is Calculus Explained, and today we are going to be covering the product and quotient rules. So up to now, differentiation has been almost mechanical, but here's where many students make their first serious calculus mistake. Let's say we have f of x is equal to x squared times x cubed. We cannot just use the power rule and say that f prime of x equals 2x times 3x squared. This is wrong. Please do not do this. Today we'll explain why this is wrong and what to do instead. Let's introduce the product rule. Let's say we have d dx, f of x, g of x. This is equal to f prime of x times g of x plus f of x times g prime of x. So you differentiate the first and keep the second, and then you keep the first and differentiate the second, or vice versa. You could also swap these around, and you'd get the same result. The point is that you have to differentiate one at a time, never both at once. So let's look at an example. If we have f of x equals x squared times x plus 1, we say f prime of x equals d dx x squared times x plus 1 plus x squared times d dx of x plus 1. Simplifying this, it's 2x. This is x plus 1. This is x squared. And this is 1. So, simplifying it all together gives f prime of x equals 2x x plus 1 plus x squared. We can check this by distributing. The original function is just x cubed plus x squared. So differentiating gives f prime of x equals 3x squared plus 2x. If we simplify this down here, we get 2x squared plus 2x plus x squared equals 3x squared plus 2x, which matches what we got. Now let's look at another example. Let's say f of x equals 3x times x to the fourth. If we differentiate, we get f prime of x equals d dx 3x times x to the fourth plus 3x times d dx x to the fourth. If we simplify this, we get f prime of x equals 3x to the fourth plus 3x times 4x cubed, which just simplifies to 3x to the fourth plus 12x to the fourth, which is 15x to the fourth. So that is how you compute that problem. Now, let's look at another rule. This is called the quotient rule, and it's a bit more complicated. If we have d dx of f of x divided by g of x, then we get f of x g of x minus f of x g prime of x, all divided by g of x squared. So you can think of it like bottom d top minus top d bottom. That is how you remember this top numerator. You always want to differentiate the top function first, f, and then you differentiate g. And you always subtract and remember to take the bottom squared. The order matters here, and the minus sign is crucial. This is hard to remember sometimes. However, it is very important that you do remember it, as it comes up quite often. If we look at an example, f of x equals x squared over x plus 1, then we get d dx of x squared over x plus 1 equals 2x, that's the derivative of this, times x plus 1 minus x squared times 1 all over x plus 1 squared. Simplifying this gives 2x squared plus 2x minus x squared over x squared plus 2x plus 1. So then we have f prime of x equals x squared plus 2x over x squared plus 2x plus 1. And that would be our final answer. Let's look at one more example. Let's say we have f of x equals 3x over x squared. If we take the derivative, then we get d dx, 3x over x squared, equals 3x squared minus 3x 2x over x squared squared. So then this becomes 3x squared minus 6x squared over x to the fourth, which is negative 3x squared over x to the fourth. You can cancel out the exponents, and f prime of x equals negative 3 over x squared. You can see this, if we canceled here, this would become d dx 3 over x, which by power rule gives us this. So that's how you use the quotient rule to find a derivative. So a strategy for product versus quotient rule is to simplify first. If you ever see multiplication or division of functions, ask yourself, can I simplify first? If not, then use the product or quotient rule. So for example, in our earlier function, back up here, we could have just simplified this into x to the fifth, and then differentiate gives us 5x to the fourth. So in that case, it would be better to simplify first. However, in a case like this down here, you would want to use the product rule, because there's no good way to simplify it. Same with here. You would want to simplify this because you could cancel out the exponents and you could just use the power rule. In a case like this, you would want to use the quotient rule because there's no good way to simplify it. So let's look at some practice problems. Let's say we have f of x equals x cubed times x squared plus 1. Now you could either simplify or you could use the product rule here. Another one would be f of x equals x over x squared plus 1. And lastly, f of x equals 3x times x plus 1 over 2x squared. So go through these on your own, pause the video, and when you're ready, we'll go through them together. Welcome back. So here, we'll first look at the case where you simplify. This would give us x to the fifth plus x cubed, and power rule gives f prime of x equals 5x to the fourth plus 3x squared. Now in the case where we use product rule, we get d dx of x cubed times x squared plus 1 plus x cubed times d dx x squared plus 1. This gives 3x squared times x squared plus 1 plus x cubed times 2x. Simplifying this gives 3x to the fourth plus 3x squared plus 2x to the fourth, which is 5x to the fourth plus 3x squared is equal to f prime of x. So you can see that simplification is usually faster. Simplification is a better idea if it's simple and easy. Otherwise, if you don't have an option, go with the product rule. Now, let's look at a case where you need the quotient rule. So, we have d dx of x times x squared plus 1 minus x times d dx of x squared plus 1 all over x squared plus 1 squared. Now simplifying this gives us x squared plus 1 minus 2x squared over x to the fourth plus 2x squared plus 1, which is just 1 minus x squared over x to the fourth plus 2x squared plus 1. And that would be f prime of x. Now let's look at the last example. This guy over here, you could either use product rule or you could simplify. Let's simplify because that is the best and easiest option. If we have f of x, then we can simplify it to get 3x squared plus 3x over 2x squared. From here, you notice you can factor out an x and further simplify to get f of x equals 3x plus 3 over 2. So then f of x equals 3 halves x plus 3 halves. And you can use the power rule to get 3 halves. So you see that what looked like a function that we would have to use both product and quotient rule for turned out to be a simple and nice function that simplified into a constant as the derivative. I hope you enjoyed this video, and I will see you in the next one.